let's look at a little bit more complicated example here using this Q is equal to mc delta theta. In this case, we're going to be mixing things. So we're going to mix some copper at one temperature with water at another temperature, and we're going to figure out what is the final temperature of the water. So the question tells us that we have 100 grams of copper at 90 degrees Celsius, and that is added into 500 milliliters of water at 20 degrees Celsius. And the question is, what is the final temperature of the water and copper mix? Okay, so to begin with this question, we have to figure out where is the energy going. So generally, when you put two things in thermal contact, if you put two things at different temperature in thermal contact, heat energy will flow from the hot thing to the cold thing naturally, right? Otherwise you have to put in some sort of energy to move the heat the other way. But naturally heat energy will flow from the hot thing to the cold thing. So the copper here is going to lose heat energy. It's going to lose heat energy when we mix them. In other words, the copper is going to end up at a temperature that's lower than 90 degrees Celsius in the end. Now, the water is at 20 degrees Celsius, so it's the cooler of the two, so that's going to gain heat energy. So it's going to gain heat energy from the copper. In other words, at the end of all of this, when we mix the two, the end result, the temperature will be higher than 20 degrees Celsius. So I'm going to make a note here that my final temperature, I'm going to call X. Capital X, like that. X degrees Celsius for now. And that's going to make life easier for us when we're doing these delta theta. So, firstly, we can't lose, in the question it tells us to assume that we don't lose any heat energy to the surroundings. So, we can't create or destroy any energy. That's what the principle of conservation of energy tells us. So, any heat energy lost by the copper here, we said that's going to lose heat energy, is going to be gained by the water. So, the amount of heat energy lost by the copper is the same as the amount of heat energy gained by the water. So Q, copper, is going to be, that's lost, is going to equal the Q of the water gained. Okay, so these values are going to be the same. So we can equate those. And from that then we can do our calculation. So what's Q? Well, we look up here. Q is going to be M. We're looking at the copper. So the mass of the copper times the specific heat capacity of copper times delta theta 1. And I'll explain why we have a 1 there in a second. And then over on this side, for the heat energy gained here, it's Q. So that's going to be the mass of the water times the specific heat capacity of the water times delta theta 2. Now the reason that I have delta theta 1 and delta theta 2 here is because these temperature changes are going to be different. If you think about it, the temperature of the copper is going to come down from 90 to some value. Let's say we plucked a value out of the sky and we said it came down to 40 degrees, right? So it went from 90 to 40. That would mean that my delta theta 1 here would be 90 minus 40. It would be 50 degrees Celsius. But we don't know that it ends up at 40 degrees Celsius. As far as we know, the final temperature is X, and we're going to solve for this X. So how do we figure out what delta theta 1 is? Well, we say it's 90 minus X, like that. Whatever the final temperature is, you would subtract it from 90, and that would tell you what the final, overall what the final temperature is. So if you're getting stuck with this as to where to put the X in this case, think of a real, situation with constant numbers, and what would you do? And then instead fill in your X instead of the constant number. Okay, so my delta theta 1 is going to be 90 minus X. Let's look at my delta theta 2. Well, what will happen to the water? The water will go from 20 up to some value. It'll go up to some value. Let's say the value was 40 degrees, right? So let's say at the end of this mixing of the different things, my final temperature was 40 degrees. What would my delta theta there be? It would be 20 degrees, because my delta theta 2 would be equal to 40 minus 20, like that, which would give me 20 degrees Celsius.